Hello and welcome to Test Corrections. This is the MCQ. So starting off with, my name is Cis Gonzalez. Starting off with number 1. So we have natural force of A, B, and C. So basically the question says if we have an object that we place it on B, right? And then we move the object to C, what is the relationship of the natural forces? So my reasoning with this one was that I was looking at a natural force up and down, when in reality I should have remembered that it can also go sideways. So if I would have not made that mistake, then it would make sense that if you move this one over here, these two, because this one's still pushing, they're all going this way. This one's still pushing that way and still pushing all of them. It doesn't change at all. But if B now has to push an extra force, the natural force has to change. So because of that, it's D. So AB stays same, BC increases. Alright, so for the next question, it gives you a graph, number 2. Relationship, speed and time. We only really need to know one thing, that for 1 second, it goes at approximately 3.5 meters per second. And we're given the mass of the object, 10. So we're asked to find the force. Now, in this, I disregarded everything that I knew previously. And I kind of panicked in the moment, so I did not understand it. But what we really just need to do is, well, we know we just need to multiply the 10 by the 13.5, which is the formula to get newtons, because it's mass times acceleration, no, speed. So m times v is equal to force. So that would literally just multiply it. So it'd be 35N, which would be the answer, C. Alright, next one, number 3. Number 3 is very similar to our labs. So the thing is, we should have just looked at the placement of the motion sensor. Because they placed the motion sensor incorrectly, then the lab doesn't work. So because of that, the answer is C. There's not really much more explanation other than just follow the procedures that we did in real life. So for number 4, it's asking us, we have a couple objects. We have object 1 that's going to free fall straight down, object 2 that's sliding on a ramp, and object 3 is thrown across and then it goes into a free fall. So which one of these will take the longest amount of time to reach the ground? And these two, since they're all from the same height, and because of that, these two will land at the same time. However, this one has another force acting upon it other than gravity. These two only have gravity acting upon it. This one has the force of friction, and because of the force of friction, it's going to slow it down and it won't get there in time. So the answer is B. Object B will take the longest to fall down. Alright, in this next one we have a person standing on a raft, and as they walk to the right, what's the speed? Well, where's it gonna move to? Where's the raft gonna move? Well, if we think about this logically, as the person moves here, they're gonna shift the center of mass to the other side. And because of that, it's going to be unbalanced, and because of that, the left side will move at a greater pace. Because currently he's in a standstill, so it's not moving at all. But now there's velocity to it. So yeah, that's it. It's D. And then That's number 5. Number 6. We have an object being released. We are told to remember that these are the planes. Up is positive, well, and then x is positive. So the thing that is tricking us here is that since we're looking at it and it's going in the downward direction, we just assume that that's negative, but that's not necessarily the case. That's just what this is saying is the direction it's going in. So this would be the y. No, sorry. This would be the y down here. This would be the x. It's the same thing, but you just need to change your perspective, and that's what gets a lot. That's what got me. So if we really think about it, they're both increasing. It might not be increasing in the same sense as we're thinking, but it's increasing, even though it's going down. So both of them are increasing. This one's moving to the right, this one's moving down. It's just that the perspectives are different. So the answer is D. And number 7, this one's a lengthy one. A lengthy MCQ. Number 7. This one was very simple, and I'm just in shock. Well, majority of them were really simple if you really think about it. All right. F1, M, F2, and 2M. Which of the statements is true? Well, the first statement was that F1 is equal to F2, but we know that's not the case because F1 has a lot more tension because it's pulling not only M but M2. Second one is that F1 has to be greater than F2, which is correct because F1, like we said previously, is pulling not only the mass, but it's pulling the second mass. 2 times the mass, actually. So yeah, that's the true. So it's B. And that's it. Thank you for watching.